We're looking at a review of exponential functions, so like a whole chapter's review of exponential functions in one lesson. So here we go. So 2 to the 0 power is, anything to the 0 power is 1. 2 to the 1/2 power, remember a half power is the square root of 2. And 2 to the negative 1 would be 1 over 2. So that's the inverse, so divide by 2 instead of multiply by 2. Some properties of exponents. If I have a to the x times a to the y, that's a to the x plus y. A to the x over a to the y. A to the x minus y, the exponents subtract. This one would be 1 over a to the x. The negative exponent pushes the base to the bottom. Anything to the 0 power is 1. AB to the x, another way to write that is a to the x, b to the x. Everything inside the parentheses gets raised to the power. This one, a power to the power, so I have a to the x times y. And then this is can be rewritten as a over b to the x power. And then the absolute value of a squared would be the same thing as the absolute value of a and then squared, which means that this is the same thing as a squared. Okay, that one might be new. Okay, we're going to do a quick little review of mother functions. So we're just going to actually do the positive exponent. So 2 to the x and 4 to the x. Go ahead and fill in your table. All right, so 2 to the x, I got 1 over 4. This one's 1 over 2. We get 1, 2, 4, and 8. For the second, you should have gotten 1 over 4 squared, which is 1 over 16. 1 over 4, 1, 4, 16, and 64. Exponential growth from a table, remember, is that we're multiplying by the same value each time. Okay, so a constant multiplier. What's the constant multiplier of 4 to the x? Well, that would be times 4. Okay. We're going to go ahead and graph these in really quick. So I have for the 2 to the x, we cross at 0, 1. And then I move over to 1 to 2. 2 squared is 4. 2 cubed is 8, doubling our growth each time. And where is our asymptote? Our horizontal asymptote is here at x equals 0. Excuse me, y equals 0. Okay. For the 4 to the x, we again start at 0, 1. And then at a 1, 4 to the first power is 4. And then 4 to the 4th power is 16, which is off the graph. So, and then after 1 in our fractions, we're going to go to 1/4 and 1/16. So we get closer to the asymptote faster in the negative side. So which growth is growing faster when our x values are positive? That would be 4 to the x. Okay, so the bigger the base, the faster the growth as x goes to infinity. All right, so again, we're only going to do one side of this. So our mother function is f of x equals a to the x, and we're going to say that a values have to be positive. So an example would be like f of x is equal to 2 to the x, or f of x is equal to 3 to the x, so on and so forth. So our graphs look like this. They have asymptotes at 0. They have y-intercepts at 0, 1. And then they increase on the right-hand side and go towards 0 on the left-hand side. So the domain is x is equal to all real numbers. Y is equal to, y has to be greater than 0 since we have an asymptote. The intercept is 0, 1, only a y. We're always increasing. And we have an asymptote at y is equal to 0. The end behaviors, we'll add those, are as x goes to infinity, y is going to infinity. And as x goes to negative infinity, y is going to 0. Okay, so just think about this for a second. If we have the function a to the negative x, what's going to happen to the graph? It is going to switch horizontally, so reflect horizontally, so it looks like this. So what's going to happen to each one of our features? Might as well go over this. The domain is the same. The range is the same. Our intercept is the same. Instead of increasing, we're going to be decreasing. Our asymptote is the same. Our end behaviors, as x goes to infinity, y goes to 0. Remember, they're going to switch here because it's a reflection. As x goes to negative infinity, y is going to positive infinity. Okay, something important to remember is that if we don't have a multiplier, so like a vertical multiplier, we have y-intercepts at 0, 1. Excuse me. I wrote that weird. Ooh. Come on, 0, 1. Okay. All right, transforming functions. So use your knowledge to figure out how these functions are transformed, and we'll go over them right now. So 4 to the x compared to 2 to the x. 4 to the x it grows faster. It's steeper, taller, okay? When I subtract 3 from x, that means that we're going to shift right 3. What does a plus 1 to the x do? It shifts left 1. Okay, if I add a number on the outside, like a k value, we shift up 1. Subtract a value, down 4. What if the negative is on the outside? Well, that's going to vertically reflect the graph. So instead of 2 to the x like that, we will have 2 to the negative 2 to the x like that. Okay, so we have our function f of x is equal to a times b to the d times x minus h plus k. And remember that all mother functions, there are a lot of different mother functions because there's a lot of different bases we can use. So you have to use your table based off of, when you graph, you have to use your table based off of your base value to create your graph. Okay, so in the equation, the variables are x and y are variables. The a is your vertical stretch. And this affects, I don't know if it's effects or affects, affects the y-intercept. The b is the base value or your ratio, your multiplier. Okay, the d value is the horizontal stretch. And also your horizontal reflection. Well, we should add that a is your vertical reflection too. Okay, h is the horizontal shift or translation. And k is your vertical shift, just like all things. This k value is also, this is also going to be your horizontal asymptote. All right, so that's it for this video.